one other thing I wanted to show you guys how to do is how to graph in a graphing calculator. And each graphing calculator is a little different, but what I'm always going to use is the graphing calculator I put in the syllabus TI-84. And so I'm going to try to teach you how to use these calculators, just in case. I'm sure a lot of you already have and are familiar with it. But basically, I can do every little thing I just did and have the calculator do it for me, save myself a lot of trouble. Now, going through this is still important to understand these concepts and why, and why we do this in the first place. But a lot of times we don't want to go through the math over and over and over again. So anyways, to create a graph of a function, obviously a calculator needs to be on, but you can start by going into the y equals menu, which will allow you to graph a mathematical function. And basically all you then would want to do is type in the formula for your function. So instead of f of x, it just uses y, but as I mentioned, it means the same thing, not exactly, but all functions are technically equations, and you can just change f of x into y, which would just be called its corresponding equation. But basically, I would then need to type in the formula into the calculator. And so this is a good example because many of us might not know, well, your calculator actually has an absolute value function. And a lot of special functions can be found within the math menu. So if you go into the math menu, and if you scroll down a little ways, actually I need to go into the number menu. So I need to actually scroll to the right. And notice the very first one is ABS, and that's just the calculator stored function value for the absolute value function. Sometimes functions are written using more than one letter, often as a specific one, like ABS parenthesis, that's kind of indicating it's an absolute value of whatever comes next, which is why there's often a parenthesis there. And notice that when I type it in, it actually converts it into the absolute value symbol. Actually, older TI calculators won't do this. They'll just leave in ABS because they don't have the special graphics. It's not so special anymore, but this was really cool. I want to say 15 years ago, 20 years ago. I don't know. But calculators have made tremendous advancements since even when I was in high school. Not to try to make myself sound old. Anyways, also, to type in, we need to type in the variable x, and I wanted to mention that the variable x is always, you can always use this button right here to craft your variable. And basically I then need to type in the formula correctly. Absolute value of x minus 1 minus 2. And then if I just hit graph, my calculator will create and notice that I have a very specific custom window, and your calculator might have a different window depending on whoever last used it or last dealt with it. But you can always return to a normal window by hitting zoom and then hitting number 6, zoom standard, which will reset it to a more normalized graph window, which is from -10 to 10 in both the domain and range. I could even set it to the custom window I see here from -6 to 6 in the domain and range, but it doesn't really matter. But basically my calculator will do the same thing that I did. It will calculate the series of points based on the correspondence between x and the function, and it will connect the dots. And it will give me a visual representation of that function. And also, a graph is very useful for finding the domain and range of a function as well. So, I could look at my chart, to see, well, what are some of the numbers which are in the domain of this function, and what are some of the numbers within the range. But again, that is not the full story. And by examining the patterns within the visual graph, I can draw more conclusions about, well, what is going to continue to happen as I progress further in this function beyond the window that I'm looking at. So like in this particular function, what I can tell, well, and this is another property of the absolute value function, is the domain is actually all real numbers. Like as I'm looking from left to right, any number will work in here, right? Whether I plugged in -4, -3, -2, 1, they all worked. They all came up with a valid answer. And basically, there is no invalid number within an absolute value. All negatives, all positive zeros, anything works, and this is always going to be the domain. of a basic absolute value. And now the range is a little bit different. And I totally skipped over the range before because the range is a lot harder to figure out than the domain a lot of the time. And again, it's really dependent on the type of mathematical algebraic expression you're dealing with. But in this case, we can see that, by looking at the table, we have a bunch of positive numbers, -1, -2, -1, 0, but it doesn't appear to go below -2. And looking at the graph as well, there's like a value that is the minimum value of this, like a bottom value in the range, where below it, it's impossible for it to go below. And really the reasoning here is because the absolute value always makes a positive number, or 0. It can't be negative because of what it does. And so if you take away 2 from that, that gives you the very smallest it can ever be. It cannot get smaller than -2. This is the minimum value with the range, and so that's that. And so if I'm trying to write the range, again, it's kind of like I'm imagining what values are valid numbers within the range. But basically, from -2 to infinity, all of those numbers are valid, right? Because it can be -2, -1, and it can be any other positive number. If I was to keep going in either direction, the range would just keep getting larger and larger and larger. Like say I was to plug in 100, well then I would get 97, and it's just going to keep on growing forever. But basically, the range is going to be from -2 to infinity, because -2 is the smallest, infinity is the largest. And again, I'm kind of imagining if I was to turn the graph sideways and look at it as a number line, the smallest number is -2, the largest is infinity, and it can't, it's missing those numbers. So I'm kind of like imagining this number line as if it were turned that way. And that would be the set notation, the interval notation of the range as well.